Imagine standing in front of a wall with dozens of colorful balloons. Your mission: pop every single one. But here's the challenge: you need to use the fewest arrows possible. Think it's easy? Well, it's not just about aim, it's about strategy. Welcome to the minimum number of arrows to burst balloons. Let's break it down and solve it like pros. My goal today is to help you understand how to solve the classic problem step by step. Whether you're prepping for a coding interview or sharpening your algorithm skills, this one is for you. Let's take an example. For input, we have this multi-dimensional array. Here, each balloon is isolated, so we need one arrow for each, total 4 arrows. But what if the balloons overlap? That's where things get interesting and where we can optimize. If balloons overlap, a single arrow can burst all of them at once. The trick is to sort the balloons by their end points and use a greedy approach. Shoot an arrow at the first balloon's x end. For the next balloon, if its x starts within the range of the current arrow, great, it gets popped too. Otherwise, a new arrow is fired. This way we minimize the number of arrows. Let's jump into the code and I'll walk you through it line by line. Open up your favorite IDE and let's write this in C#. We start with the solution class. Here's the main method, find main arrow shots, which takes a 2D array points as input. Each subarray represents a balloon with points I0 as the start and points I1 as the end of the balloon's range. First, we handle an edge case. If there are no balloons, the length of points is 0. In that case, we simply return 0 because no arrows are needed. Next, we sort the balloon by their endpoints using array.sorts. This ensures that we process the balloons in the order of their ending position, which is key for minimizing errors. We initialize arrow to 1 because we'll need at least one arrow to burst balloons. Here we store the ending position of the first balloon in the last end. This represents the position of our first arrow. Now comes the core logic. We loop through each balloon in points. If the x start of the current balloon is greater than last end, it means this balloon doesn't overlap with the range of the current arrow. So we increment the arrows count and update last end to the end of this balloon. If the balloon overlaps, the current arrow can burst it, so no new arrow is needed. Finally, we return the total number of arrows required to burst all the balloons. Here's the main method for testing our solution. We create an instance of a solution class. We define the input points as a 2D array representing 4 non-overlapping balloons. The find minimum arrow shots method is called and the result is printed. For this input, since none of the balloons overlap, the output is 4. Each balloon requires its own arrow. Let's take another example. For this input, we have 2 overlapping balloons. So all the 4 balloons can be bursted by only 2 arrows. When I first encountered this problem, I struggled with figuring out how to handle overlaps efficiently. I tried brute force initially, but it was slow. Once I learned about sorting and the greedy approach, everything clicked. It's all about finding patterns in overlapping intervals, and that's how you solve minimum number of arrows to burst balloon. This problem is a great way to practice interval problems and master the greedy approach. If you've enjoyed this breakdown, smash that like button and subscribe for more algorithm deep dives. Got questions? Drop them in the comments and I'll see you in the next one. Keep coding, let's pop those balloons together.